do some more probability stuff here. A sample space. A sample space is annoying. It is a list of all possible outcomes in a probability situation. I want you to think of the sample space for ordering a sandwich at Subway. It's quite a large sample space, right? How many breads are there? Six breads? I thought there were six breads. I don't know. Okay, let's pretend there's six breads. How many meats are there? Six. Okay, so that's 36 possibilities. Then what if you got one vegetable? But then what if you got two? Or what if you got three? But what if you got all? What about the spreads? Okay, we're not doing it anymore, but do you understand what a sample space is? Okay. We're going to make a kind of a simple one here. So 2 coins. The sample space would be heads, 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 tails, tails, heads, tails, tails. That's like the simplest sample space I could think of. Yeah. Oh, I guess maybe 1 coin would be easier. That would just be heads and tails. Those are your only 2 outcomes. For a 6-sided dice, it would just be 1, 2, 3, 4, 5, 6. Now, in the homework, it asks you to use a sample space for rolling 2 dice. So we're going to make that in our notes so we can just look back at this. And I'm going to write in 3 different colors. So if you guys have colors and you want to use colors, you can. You don't have to. But I'm going to use 3 different colors. And I'm going to start with my regular color, blue, for dice 1. Okay. Now it's a 2 6-sided fair die. I always have to say 6-sided and fair because people are like, oh, Mrs. Talbot, what happens if it's a not fair one? I'm like, okay, yeah, that's fine. This is the sample space for rolling a 6-sided fair dice. Does that make sense? Yeah? You guys got that? Okay. All right, now I'm going to switch to a different color. For my second dice, and that is the sample space for rolling the second one. Now, I wanted to show you I have a cool one. Not here. I have a cool one in here. I don't have it. Where is it? How many dice do you have, Mrs. Talbot? I got a lot of them. Okay. This one is a loaded 6-sided dice. This one, you can see in the camera that maybe you can't see very well, but there's like, oh, wait, if I pause right there, you see how it's like cut out? Yeah. There's a weight on this side. So it rolls a 6 more often. So 6, oh, a 2. 6, 6, 6, yeah. Anyway, okay. All right, so what we're going to do in our sample space is we're going to put the outcomes of each one, and then we're going to put the sum. So dice 1's outcomes are going to go here. Okay, and then dice two's outcomes are gonna go downward like this. And this will give us all possible combinations. This is all different possible dice rolls for two dice, which is definitely not this guy, which is not fair. He's just really happy to roll six. Okay, now I'm going to take my third color and I'm going to find the sum. So when I add what I got in my rolls, so this is a 1 and a 1, so my sum would be 2. Sums are in orange is what I wrote. I just made a little note that that was the color I used for sums. I don't even understand what this one does. It's 10-sided, but why does it have tens numbers on it? No idea. This one's 12-sided. That one's cool. I got all the dice over here. All the dice, no slot machine. Okay, so we're still working with the dice here. You guys are gonna think that I'm like a gambling fanatic. I really am not. I'm positive. I'm not. I don't have I know it's like when you know the math too well, it's just not a good idea. Like you find out what a bad idea it is, and then you just watch other people like not understand math and what? Oh wow. Okay, anyway, so an event is any outcome or combination of outcomes any outcome or combination of outcomes that you're interested in a random process. Gosh, I just remember we forgot one when we were listing the random processes. Wouldn't a deck of cards also be? Did they? Did I miss someone say deck of cards? Anyway, we missed that one. So what kind of outcome would we be interested in? So I don't even know what kind of games there are, but yeah, you know, a certain, yeah, a certain type of card hand would be interested. Some people want to roll 7, right, on dice. Have you heard of that being a thing?
Yeah.
Rolling 7, rolling 2 dice and getting a sum of 7. Anyway, so it would be like flipping a coin and getting heads. That would be an event that you're interested in. Anyway, we're going to call event A rolling a sum of 5. Okay, define event A as rolling a sum of 5 on 2 fair 6-sided die. Find the probability of A. Okay, so I want to talk about this again. We talked about this on Friday. This is shorthand. Mathematicians, statisticians are lazy, and we develop notation because we're lazy. I don't want to say what's the probability of rolling a sum of 5 on 2 fair 6-sided die. What I want to say is find the probability of A because I'm lazy. Okay. Because we're just starting probability, this is going to seem kind of simple, but the probability of A is going to be the number of 5s over the number of outcomes. What you want over the total. Your event over the total is what probability is. Okay, so look back up at your table in the sums, right? How many 5s are there? 4. And how many total? 30. Jake, have you had some dice experience before? Okay. A probability model is an organized table or list that shows each outcome and its probability. This is something I want you guys to start envisioning this as L1 and L2 in the calculator. So we're going to be using L1 and L2 to calculate things for us at some point here. But these have some rules. Now this is common sense. All of the probabilities are between 0 and 1. And add to 1. Think about that. Why should all the probabilities add to 1? The 100%, right? So this is called, it will be called a closed probability model, which means that all of the outcomes in it will add to 100% probability. That means if you're just missing one of them, you could minus from 100%, which is great. That's a hint for later. Okay. Now we're going to go back to our table that we made, and our event this time is going to be the sum. And so we're going to put X here and the probability of X here. And so what this is saying is, what's the probability of getting a sum of 2? 1 box out of 36 boxes has a 2 in it. So back up here, that's this 2 I'm referring to, the sum 2. Okay, can you guys see where this is going? Okay, so the sum of 3, 2 out of 36. Don't even reduce these. You want to make sure that you have 36 36s. This is a probability model. Any questions so far? Anything? You guys okay? Just make sure Jordan's. I was just checking on Jordan. Take your time. Take your time. I don't want to go too fast. Oh, I'm sorry. What? It won't even go down the hole. Okay, well, I mean, maybe ish, depending on how big you write. Right? Oh, yeah. Some of these basic probability rules are going to seem extremely basic, like stuff that you would just take for granted, like you wouldn't even need somebody to tell you. But I just want to be sure we're all on the same page, because some people know a lot about probability, some know very little. I'm always surprised every year about how many people don't know what's in a deck of cards. And I highly suggest that you, would you say 2? Oh.
No, he said 52.
Okay, so what else do you know about decks of cards? 4 suits, what are they called? Are you sure you're not talking about the Lucky Charms? Just kidding. That was my joke to 4 people? Oh no.
There's 3 face cards,
3 face cards, 2 through 10, and an ace, that's correct. 2 colors. 2 colors. Yep. Okay. Just in case those come up, I have 1,000 extra cards in this room, so we can always look through them if we need to. No. This is not gambling class, even though it feels like it right now. Okay. No. Blackjack's way better, by the way. Anyway, well, the dealer usually hits on 17. So if the dealer's hitting, or I mean, the dealer usually stays on 17. So if the dealer's staying on 17, what do you think, Justin? Should you hit on 17? Okay, this is a very, very basic definition of theoretical probability, not probability as a long run for relative frequency that we learned on Friday. So this is more like mathematical probability, 50-50, like that sort of deal. That this is what you know, so what you want over the total, right? What else do we know about probability? What is something else you know about probability that we just talked about? Yes, all. I just spelled out probabilites. All probabilites. Ah, I got so excited that I just started. I don't even know. Okay, all probabilities. Okay, what's another thing that we just learned? Oh, yes. All probabilites. Okay, what? There's no ha ha. Okay, the next thing is one that you might not have thought of. It's called the complement rule. And this is not a derivative, please don't worry. So what is a complement to something? Yes, Jake?
So it's like, I mean, element maker does well with it.
Yeah. Not okay.
I was thinking of the one where like, I was thinking like you're drawing cards and draw hard and less likely to draw.
That is changing probabilities without replacement. Complement. Okay. All right. I'm going to talk about this in terms of Mr. Guinan. So Mr. Guinan teaches about compliments, not like telling somebody they look nice, like not that kind of compliment. Talking about the other guy. The compliment is the other guy. Okay, what that means is it's everything else. In our class, we're going to call that the probability of a complement. And when you see that, that's not A. So that's the probability of not A. The little c is not an exponent. It's just saying not. Okay, and so when we want to write not in our class for probability, we're going to use that because we're lazy. So we're going to write this little c. And that's 1 minus the probability of A. So complement means everything else. Everything other than A is 1 minus A. Okay, last one. Oh, it's so nice. Okay. So let's talk about this stuff. I just put a lot of things in there. Yeah, okay. Mutually exclusive. Mutually exclusive, that things don't overlap each other. So like freshmen and sophomores are mutually exclusive. There is not a student that is both a freshman and a sophomore at the same time. So those two categories are mutually exclusive. Rolling a 4 on a dice and rolling a 6 on a dice is mutually exclusive. Meaning you can't roll a 4 and a 6 at the same time, but you could roll a combination of 4 and 6. That's not mutually exclusive. Okay. This means, let's talk about what this is saying. First of all, this is probability of A or B. This upside down U thing is called a union. Union is the word for that, and it means or. So this is part of the lesson. Part of the lesson is learning notation. The little c is not. This is called a union, which is or. Okay. Is owning a dog and owning a cat mutually exclusive? No. Okay. Is being a dog and being a cat mutually exclusive? Yeah. Can't be, well, except for cat dog. There was that one cartoon, it was cat dog.
On the wall.
You remember cat dog? Anyway, okay. You have this animal. Some animal, just picture like a box. You don't know what's in it. What's the probability that it's a cat or a dog? Yeah, so you would take the probability that it's a cat plus the probability that it's a dog. No big deal. Okay, and the reason is because there's no overlap. There's no cat dogs in there. So there might be a cat dog in there because we talked about cat dog. But
I see one, like this cat would like raise a bunch of dogs and like start acting like a dog.
oh well, maybe I don't know. Maybe I picked a bad example.
It wasn't actually a dog.
Okay. You guys know what that other symbol is? The other one was union. What's this one? Anybody?
Yeah, it's human.
I heard it.
Third.
It is and, but what's the fancy name for it?
And
Intersection. It's called intersection. You guys ever learned it?
no.
Any other class? Interesting. Okay. Now I got this. You didn't learn union and intersection?
No, I did. Right.
Okay. I don't know. Okay, so let's just go here. We'll stop and then I'll give you time to write. Mutually exclusive events. Events that have no outcomes in common. They have no overlap. This is saying the probability of A and B so that occurring at the same time is 0. There's 0 chance that those things would occur at the same time. I'm not a sophomore and a freshman at the same time. 0 chance that you're going to have a student that's a sophomore and a freshman. That means that those things are mutually exclusive. This picture here is called a Venn diagram. We've done Venn diagrams in other classes, I'm sure. This is a very specific one where the circles do not overlap. Normally they do. But this is what a Venn diagram would look like if they had no outcomes in common. So the circles would be separated. Guess what we're doing tomorrow? Venn diagrams that actually do overlap. Okay, this is the end. Oh, why did I put that? That's ugly. Jeez. How are you going to give them a chance to practice their symbols? There we go. These numbers? What? Oh, those are less than or equal to's. I'm sorry. I see why you say 5 and 3. Let me clarify my font here. This says 200 is less than or equal to X is less than or equal to 240. That's my bad. Sorry. Are you guys writing? And okay. Have any of you had your cholesterol checked? What was it? Do you remember? Just curious. Since you guys are children, you should be good. Okay, shh. Let's just finish this up, please, so I can try to remember what the joke was. Okay, so we're gonna answer A in 2 ways. We're gonna answer it with common sense, and then we're gonna answer it with math. But first, define event A as someone's cholesterol being greater than 240. Define event B with someone's cholesterol being between 200 and 240. The probability of A, so greater than 240 cholesterol, is 0.16. The probability of B being between 200 and 240 is 0.29. Does that make sense? Hello? Okay. Explain why events A and B are mutually exclusive, common sense wise. Okay, that's the math way. Okay. Okay, I left a gap because I want to write the common sense sentence on top of that. So that's the math sentence. There's no numbers that are all greater than 240 and between 200 and 240. What's the common sense reason that they're mutually exclusive? Yeah, every person has 1 cholesterol. Yeah. Mm-hmm. Now, technically, I wrote that little caveat there just because You know, if Owen was feeling like it, he could go get his cholesterol checked every day, but he's probably not into that idea. Okay, let's practice our notation. Find the probability of A or B. Okay, so we scroll up here. We say this is mutually exclusive. Mutually exclusive addition rule says the probability of A or B is the probability of A plus the probability of B. So probability of A, yep, plus the probability of B, 0.16 plus 0.29, 0.45. So technically you could say there's a 45% chance of having a cholesterol over or equal to 200, because that counts everything. Okay. Yes. Okay. So find the probability that our event is less than 200. So that's the probability of, this is gonna be fancy. A or B complement. This part's not really required. I would just ask you to write 1 minus 0.45. 0. Good. That's it. Oh, the joke. Okay. Hold on. One sec. Let me make sure I don't show something bad on the screen. Okay. Yeah, we did all that stuff, right? Yeah. Okay. These are the savage chickens. This chicken says, you want to become a math tutor? And this one says, yeah, I figure it'll be easy to get away with overbilling. Uh-huh. They're not gonna know how much they owe you. Yeah. Yeah. Uh-huh. That one's kind of mean. That's why they're called savage chickens, though.